Howdy boys and girls. After 1400 odd hours of service, this gasifier's decided to fall apart on me. If you look around here, we got us a hole, and leakage here, other holes here, and a number of them all around. What's been happening is air's been getting in under the lid. It's oxidised all of the distillate, or the condensate I mean, that's been coming off the lid, and it would appear that this condensate's been attacking the metalwork, and it's so bad that this bit here is ready to fall off. It's going to be a job in 3/4 to fix. So what's actually been happening is this gasifier has been operating in Fema mode for quite some long time, at least the last 200 hours, as air's been getting in here, and may as well have had the lid open all the time. That was characterised by a serious de-stratification of the burn. So instead of the burn happening down there, just a couple of inches above the nozzles, it was occurring about a third of the way up the height of the hopper. Now, because I'm relying on this gasifier, and it is winter time now, I'm kind of stuck. So what I'm thinking of doing is cleaning this all up. Let's just check on something here. Hear that? The metal is as thin as paper all around here now, ready to break it is. So even where it hasn't broken, I can feel it buckling under my fingers. My plan for now, for the winter, is to take all the auxiliaries off here, clean this up, and put bituminous tape all around here, right around the rim, maybe a couple of turns of it, and bind it up plenty tight. That way the heat coming from here will activate the bitumen on the tape and seal this up, thereby returning this back to an Imbert gasificator. That will get me through the winter, I'm hoping, and after that I've got to rip this all to bits and all pieces, make a ring of steel, weld it on, so attach it to this, and down to here where the metal may still be reasonably solid, seems to be, to fix this little puppy up. Yep, that was the answer to that. I had been wondering why the electrolyte, the fuel burn was de-stratifying in there. Now I know. So let's see, we got us, how much run time? 1420 hours of runtime so far on this gasificator, but unfortunately I won't be able to run it until I get me some of that there bitumen tape. In the meantime, I'm stuck with this little puppy that burns some weird fluid that comes from dinosaurs. Oh well, unlucky me, huh? Alrighty, here we are at stage number 2 of the quick fix job for the winter. I took off the lid and a few other bits and all pieces, and I poured some accelerant into the condensate drain, set it alight. That heated up the metalwork and allowed me to put this bituminous tape on there. It's the sort of stuff you use for roof fixing. So hopefully the heat has activated this on the tape that I put there well enough that it will seal. I'm hoping it will stay put for the duration of the winter. Goes right the way around there and hopefully seals up the holes. Take a look at that. There's one of the holes, there's another one. I've got a whole bunch of holes going right through the metalwork right there. This reminds me of my first car, which rusted faster than I could drive it. It was even worse than a Lada. I'd like to think that that little repair will carry this gasifier through, as that costs an absolute fortune to run. Here in New Zealand, petrol costs about $8 to $9 a gallon. and running that generator's too spendy for me. So let's hope I can get back to running on treacle, as that's a much more better fuel, even if I say so myself. Okay, the gasifier's all back together again. The numerous holes around here have been covered with the bitumen tape. I think the lesson I've learned is that any gasifier we make ideally does not have a condensate trap, as that condensate is actually quite corrosive. Given enough time at least, it will eat through even this high carbon steel. I found also that the lid was compromised, where this bit welded to that bit is a teeny weeny little hairline crack. So I put some of this bitumen tape on there for now. Hopefully that will resolve it. Talking of lid technologies, some long time ago I installed a set of magnets. So there's a magnet stack there, and there's one hidden under there. The idea is that when you close the lid, the magnets pull it the rest of the way shut, thereby allowing it to stay reasonably well sealed. This bit here, which used to be a very tight fit in the past, is now just loose, sort of like a car door that's not closed properly, it rattles. The idea is that should there be a puff back, this will lift a little bit until that stops it from travelling any more, thereby allowing the puff back gases to come out around the lid seal. That seems to work, as is evidenced by the splat marks on the wall and on that gate, and kind of all around at about hopper height. This gasser has served a long time and is finally getting to a point where it needs some serious fixing. The nozzles inside are locked in place. I can't get them out. One of them snapped in half, so it's wide open at about 3/4 of an inch instead of about 5/16. And so that's happened a long time ago. This has been operating in Fema mode for a long time, with nozzles that are basically shot. So next summer, assuming we have a summer, I'm going to pull that all to bits and all pieces, modify it something chronic, do a whole bunch of fixing on it, and convert it into something more like a flashifier, as there are so many advantages in Flash's design over the standard Imbert that the air for it is justified. Naturally, of course, because this has served me so well and delivered well over 1 megawatt hour of electricities over the last couple of years, I'm well justified in spending a whole bunch of TikToks and pingers on it to bring it up to standards. Oh, talking of standards and filtering, which we weren't. Some time ago, you may remember NH Hobby Logger mentioned the use of pea stone filters. Well, what I've got here is a couple of pea stone filters. The gas travels into a pea stone filter, travels all the way down, is coupled to the neighbouring filter via this U-tube, if that's what you're watching this video on, YouTube, then up to its partner, pea stone filter. These are filled with this stuff. I couldn't get pea stone, but I managed to get something similar. It's just crushed stone. I clean that, get all the dust off it, so it doesn't get its way into the engine. Load these filters up with it, and they are doing amazing things. These have served well over 120 hours without any maintenance thus far. They collect water, something chronic. After 3 or 4 hours or 5 hours of run time, when I open this valve here, I get at least a cup of actually quite clear water out of it. Not bad really, considering what's going in there. The output from that pea stone filter pair is then fed. Can I see this? I have to get round the other side. There's not much room to move around here. The output from the pea stone filters is fed into this, which has always been there. That's my stainless steel filter. That's filled to the tippity-toppity, and it's connected by another U-tube to this, which is 75% filled. with stainless steel poly pads, and the rest of the way filled with camel hair. And on from there, that gas goes to the final cyclone, which separates out any residual water and presents the gas to the mixer system, or the secondary flare, upon which one gets a lovely blue flame. So I'd like to think that when I fire this little puppy up tonight, we'll get us a whole lot of watts, as running that it's just not an option. It costs too many dollars. So boys and girls, if you're thinking of building another gasifier, you may want to think twice about adding a condensate trap, as that is the biggest point of failure in this gasifier. Indeed, it's failed far worse than the hot zone down there inside the gasifier's guts. Okie dokie, boys and girls. Sayonara.